This problem is from the multiple choice test from 1985, and this, in my mind, is an example of the most difficult that a related rates problem could get on the AP test. And what makes this problem the most difficult is that we have a cone whose volume is changing, but a cone has two separate dimensions. It has a radius and it has a height, and they could each be changing at different rates. So when we differentiate both sides with respect to time, notice we have two separate variables, r and h. We have to keep them as two separate variables, which means when we differentiate, we're going to need to use the product rule. So I have my equation. We've been told that dr dt, the rate at which the radius is changing, is 1/2. We know the rate at which the height is changing is also 1/2. I'm going to ask to find the rate of change of the volume. So it's not difficult to see what equation to use or what we're looking for here, because we know the volume of a cube depends on both the radius and the height. So I started with my volume equation. Now it's time to differentiate both sides with respect to time. All right, you can see where I've already written in the multiplication dot for you. If I want to differentiate, I'm using the product rule. So this is first and this is second. And I'm differentiating with respect to time. So dv dt is going to be the derivative of the first time. So the derivative of 1/3 pi r squared is the 1/3 pi that's already there. The derivative of r squared is going to be 2r, and the derivative of r itself, dr dt. So that was the derivative of the first times the second, which is h. Now I'm going to take the first, which is 1/3 pi r squared, times the derivative of the second. Well, the derivative of h with respect to time is dh dt. All right, I'm going to pause the video and clean this up. I'm just going to combine like terms. All right, so the only thing I did there was to take 1/3 pi times 2 and rewrite that as 2 pi over 3. I've just organized my dv dt expression a little bit. Now it's time to plug in all the values that I know. So what do I know? I know I still want dv dt. That's 2 pi over 3, and I care about the exact moment when the radius is 6, the height is 9. I know dr dt is 1/2. So I'm just plugging in the information from the problem now. Notice that's your very last step. This is 6 squared. dh dt is 1/2. I'm going to take a second off screen and simplify that, and we'll get our final answer, because remember what we want is dv dt. So here we go. I've plugged in h is 9, r is 6, dr dt is 1/2, dh dt is 1/2. I did some canceling down there that you can see, and I get the dv dt is going to equal 18 pi plus 6 pi, which makes 24 pi. That's answer choice C if you're looking in your multiple choice binder. The answer is 24 pi.